Welcome, my name is Black Lotus, and this is my how-to video for my PowerPoint presentation, ASMR-tist, and my topic modeling for ASMR YouTube videos. So the first thing I did was I separated the 4 notebooks and my PowerPoint presentation away from all the other files that I created in the notebooks because I wanted to post this to GitHub and that was the easiest way. And then what I'll do is I'll just go through each of the notebooks individually. So this is my first web scraper that I used. I created for this project. As stated in the PowerPoint presentation, I had to build 2 web scrapers. So here are the packages that I used: URL open, and then I used a combination of random and sleep for my web scraper so I could sleep a few seconds, and I created a JSON file at the end, and I used Beautiful Soup. So this cell right here has a tuple of the ASMR YouTube videos sorted by the most popular, and there are 10 of them, one for each YouTuber. So the way I did that was I went to each individual's YouTuber's channels, went to the video section, and I sorted by most popular, and which you can click on this drop down right here. And when you do that, it automatically changes the URL up here to a specific sorting by videos, and this one sorts by the most popular. And that's what I did for my web scraper. I had my web scraper take the 10 first videos of this URL and extract this href right here. That's what I wanted to get in this scraper for each of the videos for this first web scraper. And that's what this top vids variable will do. And here's the Beautiful Soup that would parse through the HTML. And this sets up a dictionary. So it takes in a tuple and spits out a dictionary. And of course, you want to have your web scraper sleep for a certain amount of time. Since it's YouTube, I wanted to be extra careful so I didn't get banned in case their robo parsing picks up my web scraping. So I had my scraper set between a set interval between 4 and 7 seconds, which is a lot, and this does it in a normal distribution with the uniform from the random function, so I don't have to worry about whole integers and being tracked. And this right here calls the function, puts it into a dictionary, and then I save that dictionary as a JSON file. Now my second web scraper, you made use of sleep in uniform as well, but instead of using the URL open function, I used the YouTube class from the third-party package PyTube. So I opened up my JSON file, did a little bit of cleaning, and created this scraper right here. Now this one's not nearly as fancy, but all I wanted to do was extract the descriptions and store them as a list. And as you can see, I had to do this a couple times for some there was something pushed to the PyTube repo that hadn't been merged yet, and for some YouTube videos you actually couldn't extract the descriptions, and my scraper actually crashed halfway through. So I fixed that up and got the second half of the descriptions that I needed, and I of course saved that again as a JSON file. And this cleaning notebook right here is where I spent the vast majority of my time. There was a ton of cleaning, as I said in the PowerPoint presentation. In fact, all of the YouTubers do not format their descriptions the same way, and a few did not even format their descriptions consistently. So I had to create 10 different functions for one for each of the YouTubers, which is better than creating a function for each individual video. I can just create one for one creator. So opened up the JSON file, stored it in a dictionary, and then of course went through each of the values for each YouTuber. Each YouTuber was a key. And as you can see, I use regular expressions, and then since it would have been returned as a list of lists, I use a combination of reduce from functools and concat from operations. So concat from operations, reduce from functools, to combine the list of lists into one giant list. And that would actually give me a corpus. So one for each YouTuber. So I did that for each of the 10 ASMR-tist. And as you can see right here, I accidentally left GB's descriptions up, ASMR GB. And that just shows how I went back and forth trying out different regular expressions to see what I wanted to extract specifically from the descriptions as a whole. And I purposely left open Zach ASMR's final here. After I finished cleaning and filtering through everything and combining, I took the list of lists, combined them into one giant list of words. So this is what the final product of each function returns. And then I combined each one of them and created yet another JSON file. In the final notebook, I did the modeling, and this is by far the messiest, but was by far the most fun. I opened up the JSON file once again, and just used a combination of the standard library, the SciPy stack, and NLTK, Jensen, and word cloud. So here are my corpus for each ASMR-tist. And as I went along, I saved things as pickles, and I used scikit-learn, count vectorizers, along with English stopwords to find to remove some of the stop words in the English language, such as the, and the, or and. And then I used a combination of the standard library as well as the collection module and different pandas and scikit-learn tools to find the most popular words. Of course, I had to add English stop words to the list of stop words, ones that didn't make any sense or were just repetitive enough that they weren't very helpful. Things like video and ASMR and Google and Spotify and various other words as well. And then I used a combination of Matplotlib and word cloud to combine these word clouds together. So these are actually subplots of the Matplotlib. And then in between that, I actually saved each individual one as a file. This is something that did not make it to the final PowerPoint presentation. Was a bar chart of each individual YouTuber's most popular words for the descriptions. And then I moved on to latent Dirichlet allocation. I started off with a few number of topics and slowly added passes. They really didn't make too much sense, so I continued adding topics, and I removed words that were not nouns, verbs, or adverbs. I only counted noun, verbs, and adverbs. And just started playing with the number of topics and the number of passes. As you can see, the number of passes got really large at some point. And I eventually settled on 8 topics with 150 passes. And interestingly enough, topic 0 was not assigned to any of the ASMR-tist. I believe in my PowerPoint presentation, I stated that ASMR Darling was a combination of topic 7 and topic 3 with a 65 to 35% split. However, that was not the case. It was actually a 61 to 38% split. And finally, this is just me cleaning up the final results for my topic modeling to make it a little bit prettier and a little bit easier to read in the notebook. So that was my how-to for my ASMR-tist topic modeling, the 4 notebooks that I put together. If you have any more questions, leave a comment below. Again, a lot of these methods for the topic modeling were actually taken from Alice Zhao's Pi Ohio 2018, I believe. Really, really good natural language processing tutorial that she put together, so please take a look at that video. It's highly recommended. And if you're interested in seeing any more of my data science projects, please leave a comment below. I will gladly post them if enough people show interest in it. Thank you, and that's all.